Here's the example, three-dimensional setting. So the tension in the guide wire here, so this is the wire from A to B, okay? So this is probably a power tower or whatever, part of that. So the tension in the guide wire is 2,500 Newton. So what does that mean? That means the magnitude of the force is given, right? So the magnitude of that force in guide wire is 2,500 Newton. That's what indicates. Okay, so this is given. And of course, in addition, we know some geometries here. Okay, now questions are, number one, how can we calculate the three components of this force, cable force? So that's the first equation, right? The first question, right? Calculate, determine the components of the force acting on the bolt at point A or particle A. Okay, so that's the first question. Second question, furthermore, how to calculate the three direction cosine angles, theta x, theta y, theta z, which is defining the direction of the force. In other words, they call the direction cosines. Okay, so this is a very simple example. So let's do one by one. Let's talk about question A first, followed by question B. So question A, how to calculate the three components of that force acting, the cable force acting on point A, right? So at point A, we know there's a cable, okay? So now we don't see the force. So then you basically just put a force on this point A and going to that cable direction. So there is a force acting on point A going to point B. And that's called the cable force. You may say, I didn't figure out why it's from A to B. Why not it's from A and going down further? Let me tell you, you should have a common sense about the cables. The cable can only sustain tensile force, right? So when you compress a cable, it doesn't apply with any force because it's not like a solid rod. If you have a solid rod, then you compress, that's fine. But when you have a cable, you cannot compress. The only way cable can provide force is under tension, right? So back to this one, if you do not know there's a force at point A is going from A to B or from A to the other direction further, if you just in case you do not know it, you need to make some imagination, for example. If you think that's force provided by the cable going to that direction, then this support gave the force back to point A towards B direction. That's in compression. The cable cannot provide that force. That's Newton's third law, right? Action, reaction. So that's why if you have a cable which is always under tension, so then imagine that cable should provide a force at point A going to this direction. Okay, that's only direction. Okay, so now we first figure out there's a force at point A and it's going to that direction. That's a cable force. So then we are ready to calculate the three components of that force. Okay, so how to calculate the three components of this force? Well, we use that mathematical equation, which is called F equal to F times lambda, right? Because especially when you look at this picture, we didn't see any angles. So obviously, if you have to determine which formulation you want to use, you have to use the second method, right? Use this equation to calculate that force. First of all, this force vector is always equal to the magnitude of the force multiplied with the lambda. And lambda is called the unit vector. What's the magnitude of the force? It was given, if you still remember, 2,500 Newton, right? So you don't need to worry about this. This is 2,500 Newton, and leave it alone. All you need to do is to get this lambda. To get the lambda, lambda is called the unit vector of that force direction. So now, how to calculate the unit vector of that force direction? So the conclusion is, all we need to do is to find 2 points in that direction, okay? And then we use these equations, okay? So back to this one. This is a force direction, right? Can we find 2 points? Well, obviously, there are 2 points there. Point A and the point B. If you really want to create another point, that's really nothing wrong. You just take additional time, you can still figure out. But obviously, The question gave us 2 points already. So why not to take advantage of those 2 points? Okay? So let's say we're going to pick point A, we're going to pick point B. So once we know these 2 points, then we need to identify the force direction is from which point to which point. So this is the force direction I just told you based on our kind of common sense because of the cable situation, right? So this force should be from A to B, not from B to A. If you talk about another force at point B, then that is B to A. We're not talking about that because the question clearly tells us the force is acting on point A. They didn't say the force is acting on point B. So at point A, then the force is from A to B. Okay? So from A to B, so this point A you pick should be the start point. And point B you pick should be the end point. In other words, if we go back to look at this original principle, this M is the start point, and this N is the end point, right? So you need to provide with 3 components at this end point as x2, y2, z2. You need to provide 3 components at point M as a start point, and you follow this equations, right? Okay, now back to here. We basically find out point A, we have 3 components. Let's just basically find out the 3 components, right? So what is the x components of this point A? That's a 40 meter, right? Okay, and what is the y components of what is the y components of this point A? You thought this is a little bit going up. No, they didn't tell us. This is point A here. So this one, if you keep watching a little bit more carefully, you can reasonably say this point A is in xz plane. If you still want to argue, you say, well, no, this is a little bit up because this pyramid, right? But they don't tell you the height. Then either you have to assume. But normally, if the number is not given to you, then obviously that's 0. Okay, because it is very small. So you can reasonably assume the y component of point A is 0. But there's a z component is given here, which is 30. Okay, from here to here 30. So that's z component of point A is 30. So basically you are writing down the 3 components of point A, which are 40, 0, negative 30. I forgot to say it's a negative 30 because going to the opposite direction of z. This is a positive z direction. It's going to the opposite direction, right? So basically that's negative 30. So that is it's not coming up. Okay, so again, it's in the xz plane. So these are the 3 components of point A with the start point. Back to point B. There's another point you pick. At point B, what are those 3 components? What are those 3 components? First of all, what is the x component point B? Well, because this is exactly erected in that direction, there's no x component. That's 0. So the x component of point B is 0. And then what's the y component of point B? Y component of point B from here to here, that's 80. Right? So 80 meter, that's y component. What's the z component of point B? Z component of point B is 0 again, because it's nothing in that direction. So now we find out x1 equal to 40, x1 equal to 40, y1 equal to 0, and z1 equal to negative 30. Back to this one, x2 equal to 0, y2 equal to 80, z2 equal to 0. So then we basically use this equation. So x2 subtract x1 to get this, y2 subtract y1 to get this, and so on. We can calculate lambda. And the detailed process is right here. So lambda should be equal to dx divided by d. So dx is x2 subtract x1. So x2 is 0, x1 is 40, so 0 minus 40, negative 40. Right? So that is dx, which is x2 subtract x1. This one is called dy, which is y2 subtract y1. y2 is 80, y1 is 0. So that's why 80 minus 0 is 0 is 80. This is the dz. dz is a z2 subtract z1. So z2 is basically, at this point, z2 equals 0. So 0 subtract z1. z1 itself is negative 30. So 0 minus negative 30. That's finally end up with a positive 30. Yes?
Why is it negative 40 for that?
Negative 40. Okay, by definition, this is called dx. Okay? So going back to look at this equation, this is the definition about dx, right? So it's x2 subtract x1. Okay? So now, what is x2? x2 is 0, right? So 0 minus x1. And x1 is a positive 40. So 0 minus positive 40, that's equal to negative 40. Okay, so we basically just follow that equation. Okay, so once we got the dx, dy, dz, then we can calculate the norm, or we can count the real distance from A to B. And that must be square root, because that's called d, right? So square root dx squared plus dy squared plus dz squared, and then square root. And you punch your calculator, this is what you got. Okay, so this is what you get. Now you need to divide it by this norm in every term, so that this is called the normal unit vector. Okay, again from this equation, you like if you go back from here, right? This d is a square root, so don't forget divided by d. Okay, so then you punch your calculator further. That's what you got. This is called lambda. Once you get lambda, you plug in lambda here, multiply with f, you get this vector f on the left hand side. So again, f is what? F is 2500 given from the problem statement. Multiply with lambda, you get 3 terms in lambda here. You just put this one, and then you just calculate term by term. You finally end up with those. And then this one is called what? This is called the x components of the force. And this is the y component of that force. And this is the z components of that force. Okay? So, we get the first question solved. Correct? The first question asks us calculating the 3 components of that force. And your conclusion is, this is the first component, x components of the force. Don't forget negative sign here. So negative 1060. And again, do not forget the unit. So in the middle process, whether you are going to write those units or not, it doesn't matter. I don't care. But you need to make sure your final solution should be with a unit. Because we're, again, talking about physical problems. We're not talking about math. Because this is the engineering or physics, right? So do not just write those numbers without a unit. So you are always your final solution should come with a unit. Okay, because we're talking about physical quantity. In the middle process, if you understand very well, you don't have to write a unit. That's okay. But final solution must be with unit. And this one, of course, everything is Newton. Then, of course, you finally write Newton. So the y components of this force is 2120 Newton. And the z components of this force is 795 Newton. Any questions? Okay, so this is the first question we got solved, right? Second question. Calculate or determine the angles theta x, theta y, theta z, which are defining the direction cosines of the force. Okay? That's extremely easy after you get these components or after you get this lambda. Because from definition, okay, lambda, from definition, this is another way to calculate lambda, but original definition of lambda is here. If you do not believe it, let me show you again. This is the definition of lambda, right? So this is the definition of the unit vector. We don't use this equation to calculate lambda. However, this is the definition. In other words, we can go back to look at this equation to calculate those 3 angles. Okay? And that's exactly what we did. First of all, from definition, lambda is defined like this. On the other hand, we just calculate lambda, which is this, right? So then what? So this should be equal to this. So these are in 3 directions, orthogonal. In other words, cosine theta x equal to negative 0.424, right? And the cosine theta y should be equal to 0.848. And the cosine theta z should be equal to 0.318. And then you, again, use your simple but scientific calculator to get those 3 angles by taking the inverse of cosine function. And these are the solutions. Okay? Again, by definition, these angles are always from 0 to 180 degrees. So keep in mind, if you see there's something with a negative sign here, don't give me an angle with a negative. That is outside the domain. We define these angles are in from 0 all the way to 180. And that's the domain of the angle. So in other words, if you get this negative value, cosine theta x equal to something negative, that theta should be greater than 90, but less than 180. and don't give me something else. Because the reason I'm saying that, because the cosine function or sine function is periodic, right? So don't give me something with 1,000 degrees something. I'm not saying they are not correct. Okay, they may be correct in terms of mathematics, but it may not be correct in terms of physics, because by definition, these direction cosines are defined from 0 to 180 degrees. Okay, so when you punch your calculator, sometimes your calculator can give you something with a negative sign. So don't blame the calculator. You have to transfer back to a certain range of that angle. Okay, so the bottom line is the second question got answered, right? So there are totally 2 questions. Number 1, calculating the 3 components. Number 2, calculating these 3 direction cosine angles.